Did you know that out of the 7 billion humans on planet Earth, less than 3 billion have regular access to the internet? Engineers like Anton Staaf from Google X are trying to solve this problem and make the web truly worldwide.
The Loon project is an attempt to build a technology that will allow us to deliver the internet to the 2/3 of the world's population that doesn't have access to it right now. We're doing that using high-altitude balloon platforms that build a mesh network in the sky where you communicate from the ground up to one of the balloons, from balloon to balloon, and then back down to the ground.
So where does this interesting name come from, Anton?
Loon is short for balloon. It's also a nod to the fact that this is a rather ambitious and some might call crazy project.
The balloons act as a mesh network. A mesh network looks a lot like a fishing net. Each knot in the net is called a node. Communication links connect these nodes to each other, and at the outer edges of this net, there are people who want to use the internet. The balloons are way up in the sky with their antennas pointing down and can communicate from the ground station up to a balloon, and then from a balloon to balloon, and then back down to the internet user. You can see that the balloons that are distributed around the world could actually communicate to multiple neighboring balloons. And so now, if a customer down here wants to talk to an internet provider over here, the communication that goes to the first balloon could take any number of paths. And this is the essence of what a mesh network is. It allows us to transfer messages through the network of balloons in the fastest way.
One analogy you can think of is you have a group of friends, maybe a whole school worth of students. Some of those people will be friends with each other, and you can think of each of the people as a node in a network, and each friendship as a link between those nodes. So the whole mesh of the student population is this network of nodes and connections between them. A communications network is similar to that. The Loon communications network, each balloon is a node, and the communications links, the radios between them, provide those links in the node, in the network.
How do you control where the balloons go, Anton?
We control the balloons using Loon Mission Control, which is software algorithms running on Google's computers that use wind data in the stratosphere to tell the balloons when to change altitude, because the stratosphere is segmented up into multiple different layers of wind going in different directions. And so since we know where the wind layers are, we can tell the balloon to change in altitude, move to a new wind layer, and that puts it into a new trajectory. And if we do that for all of the balloons that are flying, that allows us to control where the whole fleet goes and maintain the correct distribution of balloons.
The balloon's radio can reach 20 kilometers to the ground and the other balloons. That's about the distance you can walk in 5 hours. But so how many balloons would you need to cover a large area like a country or a continent?
We don't really know exactly how many balloons we need yet, but we envision that in particular latitude bands we might need 1,000 or a few thousand balloons.
1, 2, 3.
Last summer, Anton and the team performed a pilot test in New Zealand. When they launched the balloons up to the stratosphere, they encountered a number of different phenomena they had not predicted. For example, while flying over very cold storms, the balloon got extremely cold, and keeping the batteries and electronics warm became difficult.
In the harsh environment that these balloons are flying in, the battery technologies are not great. At very cold, batteries don't work because the chemistry inside the battery actually freezes, and then the electrons don't flow anymore and the whole system stops working. So we need to use a good bit of power when it's very cold to keep the batteries warm.
You might wonder how someone gets started in a career as a balloon roboticist.
I was 7 when I joined the robotics club. The members of the club were fantastically supportive of this young kid who wanted to build robots and didn't know anything at the time, but just knew that this was definitely the direction he wanted to go.
Come build the Curiosity Machine design challenges and explore deeper into the world of loons.